Hello and welcome. Today we are diving into a super powerful, but kinda sneaky, data science technique. It's something that helps make sense of pretty much everything, from your credit score all the way to your medical results. We are talking about data discretization, which is really just the art of turning a chaotic flood of numbers into something clear and meaningful.
You know, when we first get our hands on some data, it usually looks a lot like this. Just a long, messy stream of numbers. And if you look at them on their own, what do they even mean? It's just noise, right? Trying to find any kind of pattern in there feels almost impossible.
So that's the big question for today, isn't it? How do we take all of that raw numerical chaos and actually transform it into something clear, something insightful that we can actually use to make decisions?
Well, the solution is actually pretty intuitive. It's all about this core idea of moving from raw numbers to meaningful names. And this is the whole goal of discretization, and you're about to see just how powerful this little trick can be.
And check this out, this is the perfect example. Instead of getting bogged down with every single individual age, 19, 38, 74, we just group them. We put them into categories that make sense, and all of a sudden, the data tells a story. We have a young adult, and a senior. It's like finding clarity in the chaos.
Now, this really powerful process of grouping, it isn't just some informal trick we do. It's a formal, absolutely essential step in preparing data. So let's go ahead and give it its official name.
The technique is called discretization. It's a bit of a mouthful, I know, but formally, it's just the process of taking continuous numbers and turning them into distinct categories. And in the data science world, we often call those categories or groups bins, just like we binned those ages into groups.
So why do we even bother with this? Well, the benefits are huge. For one, it simplifies the data, which makes it way easier for both people and machine learning models to spot patterns. It cuts through all the little insignificant variations, the noise, and it helps make the data way more meaningful and easier to talk about.
Okay, so we've got the what and the why. Now let's get into the how. When it comes to discretization, it's not a one-size-fits-all deal. Data scientists have two main toolkits, and each one has its own philosophy, really, designed for totally different situations.
Now, what's really fascinating here is the core difference between these two approaches. On the left, you've got unsupervised methods. They don't care about what you're trying to predict, they just look at the properties of the numbers themselves. The laundry analogy is perfect, you're just sorting by color. But on the right, supervised methods are totally goal-oriented. They use the thing you're trying to predict to create the absolute best bins for the job. It's like sorting ingredients, but for a very specific recipe. The final dish dictates how you group everything.
All right, let's start by cracking open that unsupervised toolkit, where the data itself is our one and only guide for creating these groups. So the simplest method is called equal width binning. You just take the entire range of your data, let's say from 0 to 100, and you just slice it into equal-sized chunks. As you can see on the chart, the widths of our bins are exactly the same. But look at the heights. They're all over the place. This can lead to really unbalanced groups, where one bin is totally crammed with data points and another one is almost empty.
Now let's flip that idea on its head with equal frequency binning. Here, the goal is totally different. We want the exact same number of data points in each bin. Notice on this slide how the heights of the bars are now equal, but the widths have become all irregular to make that happen. This approach is fantastic for handling skewed data and creating much more balanced groups.
And the unsupervised toolkit doesn't just stop there. There are more advanced techniques, like k-means binning, which actually uses clustering algorithms to find the most natural groups in the data. Or things like logarithmic binning, which is great for financial data that has these huge ranges. You can even create your own custom bins based on expert knowledge, like specific age brackets for a marketing campaign.
Okay, so that's the unsupervised world. But what if our goal is really specific, like predicting if a customer is going to buy a product or not? Now we pivot to the goal-oriented, supervised methods.
This is where things get really clever. Supervised methods actually look at the final outcome, like bought or didn't buy, to find the most useful ways to group your data. A decision tree, for example, does this automatically. It literally searches for the best split points in your data, say the perfect age cutoff, that does the absolute best job of separating one outcome from the other. The goal isn't just to group the data anymore, it's to group it in a way that gives you the most predictive power possible.
So we have this incredible toolkit at our disposal. But like any tool, discretization is not a magic wand. It's a strategic choice, and it comes with some very real trade-offs. So let's take a look at the payoffs and the pitfalls.
The biggest payoff, by far, is interpretability. I mean, it is so much easier to explain a business trend using categories like low, medium, and high spenders than it is to use a list of thousands of different dollar amounts. It can also make your models more robust by preventing them from getting too complex, and it can even help certain models perform better.
But, and this is a big but, there's always a price to pay. The biggest pitfall is information loss. By grouping numbers, you lose that fine-grained detail. A 21-year-old and a 34-year-old might both just end up in the young adult bin. And if you choose your bins poorly, you can actually make your model perform worse. It's a really delicate balancing act.
Now, this might all seem like a super technical concept just for data scientists, but I guarantee you, you encounter discretization every single day out in the real world.
Seriously, think about it. When you go to the doctor, your blood sugar isn't just a number. It's categorized as low, normal, or high. That's discretization. Your credit score, it gets binned into poor, fair, good, and excellent. Even your grades in school, turning a raw percentage score into an A, B, or C, is a perfect example of this exact process at work.
And this really brings us to the core message here. Discretization is this incredible bridge that takes us from complexity to clarity. But you have to be smart about how you use it. It's a tool that really does require a bit of thought and care.
Ultimately, that's what it's all about. That's the power of this technique. Taking the messy, continuous data of the real world and transforming it into clear, simple categories that we and our machines can finally understand and act on.
And that leaves us with one final thought to ponder. As we use these tools more and more to simplify our incredibly complex, data-driven world, it's worth asking ourselves, in our quest to find clarity, what is the price we pay for that simplicity?